Hello guys, good morning. Good morning to all of you. So today we'll be discussing particle in an infinite symmetric potential well. Good morning, Harry. Okay, so in the last class we discussed about infinite asymmetric potential box. So we took the limit between 0 to A, right? So this was the scenario. So we had infinite potential here. All along infinite potential, the particle was allowed to move between 0 to A, right? So this is the midpoint, which was A by 2. Now these alls are rigid, all rigid. These are rigid alls. The particle cannot escape to this region, means the wave function will vanish there. Now the only difference here would be for an infinite symmetric potential box, instead of 0 to A, you see the width will remain A itself. This width will remain A, but here now instead of 0 to A, this will become minus A by 2 to plus A by 2. And what it does, it makes this potential symmetric. Symmetric in the sense, you will have here V of x or V of minus x is equals to V of x. So the potential is symmetric here. So we can write this potential in this way. The potential is defined as, good morning Murli, Harry. How do you define the potential? So here V of x, this is infinity, where it is infinity, or first let's talk about 0. V of x is equals to 0 when x is between minus A by 2 to plus A by 2, and it is infinity otherwise. Otherwise means x, this region x greater than A by 2, and this region x less than minus A by 2. In these regions potential is infinity. Now we have got total 3 regions. One is this x less than minus A by 2. Another one x greater than A by 2. So in these two regions, the wave function must vanish. In these regions, the wave function is vanished. Now we have to find out the Schrodinger equation in this region between minus A by 2 to plus A by 2. So in this region, we have to apply the Schrodinger equation to get a solution. And you know, here the potential is 0, and as a result of that, the Schrodinger equation will turn into minus h cut square by 2m d square psi by dx square is equals to E psi, and that is d square psi by dx square plus twice m E by h cut square psi is equals to 0. So as simple as that, the way we deal with d square psi by dx square plus k square psi equals to 0, where this k is equals to square root of twice m e by h cut square. And as a result of that, we get a solution in this form. I am not writing in terms of exponential, I am writing in terms of sine and cos. So a sine kx plus b cos kx. So this kind of solution you will get. Now the interesting part is this solution will depend on the parity. For even parity we will have some solution, and for odd parity we will have some other solution. So because the potential is symmetric, as you can see, v of minus x is equals to v of x, parity operator will commute with the Hamiltonian. Here the parity operator, we have already introduced parity operator. Parity operator is a good quantum number, we have also told you. So parity operator commutes with the Hamiltonian. We also proved this. Parity operator will commute with the Hamiltonian. What does it mean? That is, commutator of P and H is 0. So if this is so, we can write that the wave function can have either even or odd parity. Right? Even or odd, symmetry or parity. Now why it is happening? Because you see, it was 0 to A. So we have just shifted the wall. We have just shifted the potential wave, and that because of that, parity is commuting with the Hamiltonian. It does not change the energy. You see, here also you will get the same eigenvalue. Okay, no? The eigenvalue will remain same, n square pi square h cut square by twice m a square. So only the eigenfunction will change. Okay, two sets of eigenfunctions you will get for different values of n. One for the odd parity, another for the even parity. Now when you consider the solutions for even parity, how does the solution go? And when you consider odd parity, how does the solution come? That we have to do. So we are going to take two cases. We are going to take two cases. So we will be doing it side by side and see how these two are different. Okay. So the first case, case 1, which we will be discussing for solution for even symmetry, and case 2 we will discuss for the solution for odd symmetry. Okay. So even symmetry means your psi of minus x will be psi of x. Odd symmetry means psi of minus x will be minus psi of x. Okay, now look at this. Psi of x, we have got a sin kx plus b cos kx, right? So what will be the value of psi of minus x? So you just need to put minus x in place of x. So this will become minus a sin kx plus b cos kx, because sine of minus theta is equals to minus sin theta and cos of minus theta is equal to plus cos theta, and cos x psi of x means it will remain same, a sin kx plus b, let's write it here, cos kx. On the other hand, here also psi of minus x means minus a sin kx plus b cos kx is equals to minus a sin kx minus b cos kx. So from this what you can conclude? You see this b cos kx is same, and here minus a cos sin x is equals to plus a sin x. So we can say that 2a sin kx is equals to 0. Sorry guys. So from this what you can conclude? We can conclude that sin kx is non-zero. Therefore, we can say that a is equals to 0. If a is equals to 0, what does the psi x becomes? B cos kx. What about this? Look here, 2b cos kx is equals to 0. That means b is equals to 0, and hence psi of x is equals to a sin kx. Is there any confusion? Now using the boundary condition, what is the boundary condition here? You see, look at the boundary. The boundary is x is equals to minus a by 2 and x is equals to plus a by 2. So the wave function must vanish there. You have the particle here. The particle is allowed to move along one dimension within this well. So this is your x axis actually. If I want to draw it, this is your x axis. And this is your y axis. Here we are plotting v of x. V of x versus x. So boundary is x equals to minus a by 2 and plus a by 2. So wave function must vanish there. So if you use that condition, then what we can write? So using the boundary condition, what is the boundary condition? The wave function vanishes at the boundary, that is x is equals to plus minus a by 2. Same thing we are going to apply here on the other side too. Then what you can write? You can write if psi of x equals to 0, so cos ka by 2 equals to 0. Okay, so cos, for what value of cos you can write 2n pi, right? So k by 2 is equals to, acha 0 na, so it will be 2n plus 1 pi by 2, right? So we can say that k by 2, the values are, if you put n equals to 1, pi by 2, n equals to 0, then n equals to 1, 3 pi by 2, 5 pi by 2, and so on. Here you see, if you put sin k by 2 is equals to 0, so sin n pi here, so ka by 2 is equals to n pi by a. अच्छा, k by 2 is equals to n pi. Is it clear? Why trigonometric function cannot be 0? If that is 0, then wave function will be vanished, na? We cannot vanish the wave function. The wave function, this term cannot be 0, right? That is related to wave function. If this thing is 0, then everything will be 0. Okay, one more logic. I think that this logic is not so good. Another logic, you see, under which condition, if you just look at this, you look here minus a sin kx, okay, here plus a sin kx. So you can imagine sin kx same, minus a is equals to a. Under which condition this is possible? You like minus a sin kx is equals to plus a sin kx. Sin kx is same. Under which condition this a equals to 0? Here also. But this will not be 0. Okay. Another possibility is that if this is 0, then also both sides will be equal, but this cannot be 0. If this is 0, then the function will not be there. Is it clear? So ka by 2 is equals to what you get if I write it in a more elaborative way. It is pi, 2 pi, 3 pi, and so on. Let's elaborate. So using this condition, what you are getting, therefore, I am writing it kn is equals to n pi by a, where n can take values 1, 3, 5, means odd values. You see, 1, 3, 5. So kn is equals to n pi by a. We are writing n, so adding kn. Here what you can write, you see pi, 2 pi, 3 pi. So k is equals to 2 pi by a, k is equals to 4 pi by a. If you just take this, k by 2 is equals to pi, so k is equals to 2 pi by a. Okay, again 2 into 2 pi, 4 pi, so k is equals to 4 pi by a, then 6 pi by a. So you can see it is taking even values. So if I am writing it to be n pi by a, then we need to specify that n is taking the value of 2, 4, 6 and so on. If you take n equals to 2, you get the first one, you get 4, you get the second one, 6, third one and so on. And hence you get the wave function here, psi n of x is equals to bn, it was b cos kx, so we are writing in terms of n, kx, k becomes kn, so it is knx, and here psi n of x becomes an sin knx. Now if you normalize this, wave function, on this side, normalized wave function is psi n of x, so obviously this will come out to be square root of 2 by a, okay, cos kn is equals to n pi, so n pi x by a. Here the wave function normalized wave function is psi n of x square root of 2 by a sin n pi x by a. And here kn is equals to n pi by a, n is equals to 1, 3, 5, all the odd values. Here also n is equals to n pi by a, n is equals to 2, 4, 6 and so on. So this is the solution for the infinite potential box symmetric one. You can see one thing, that n is equals to 1 corresponds to ground state. So square root of 2 by a cos pi x by a, that will be ground state. What about the first excited state? First excited state you will not get by putting 3, but you have to put this one, n equals to 1 ground state, n equals to 2 first excited. So first excited state, you see it will be square root of 2 by a sin 2 pi x by a. So you see the ground state is even, because cos function is even function, sin function is odd function. So ground state is even, first excited state is odd, second excited state is even, third excited state is again odd and so on. But the interesting part is the energy eigenvalue is remaining same. The energy eigenvalues are given by, look, k is equals to, kn is equals to n pi by a, here also n pi by a. So for all values of n, kn is equals to n pi by a. So we can write k equals to square root of twice me by h cut square. So from that en is equals to n square pi square h cut square by twice m h square. So upon shifting the well, the energy eigenvalues does not change, but the wave function will change. So remember this one, when you have odd values of n, you have to write the wave function in terms of cos. When you have even values of n, you have to write the wave function in terms of sine. Look, how to remember, you see Here cos function, so you see if you look at cos, so you can see in cos inbuilt O is there, so O is odd. So in this way you can remember, when the values of n are odd, you have to write it in terms of cos. Okay. Similarly, odd values of n, actually odd n, and sine also, SINE, E for even. So this is how we can remember it. For even n you will use sine, for odd n you will use cos. So in this way you can remember. Is there any question, guys? Now, if you draw the wave functions, it will be a little bit different. Okay, we have shown you the wave function for the asymmetric potential box. For the symmetric potential well, it will be changed a little bit. So we have here minus a by 2, this is 0, this is plus a by 2, and this is your x axis, and this is, let's say, v of x. The potentials are infinity here. So we'll have the ground state, you will have the first excited state and the second excited state. Okay. So when you are choosing n is equals to 1, then the ground state energy is equals to pi square h cut square by twice m a square. So energy eigenvalues does not change. N is equals to 2 E2 4 pi square h cut square by twice m a square, and n equals to 3. Let's take another case, E3 9 pi square h cut square by twice m a square. But when you consider the wave function, psi 1x will be square root of 2 by a. Here what will be cos or sine? Yeah, for the wave function only you have to check whether it is n is even or odd. Eigenvalues will remain same. So psi 1, so n is equals to 1, odd, so cos pi x by a. Psi 2, n is equals to even, so this will be sine n equals to 2 pi x by a. Psi 3 again odd, so this will be decided by the cos function, cos 3 pi x by a. So you can see this is your ground state, this is your first excited state, and this is your second excited state, and so on. If you go for n is equals to 4, you will get third excited state. Now you see cos pi x by a. So previously also we have got something like this. The graph will not change because at x is equals to, you have to check, cross verify what is the value. So x equals to 0, so cos 0 is 1, so we get a curve like this. Cos 0 is 1, So you get a curve like this. So here also that logic or that theorem will be applied. Like if n starts from 0, then number of nodes is n, means the wave function will vanish n times, and if n starts from 1, number of nodes will be n minus 1. Okay, starts at. So here also n is equals to n starts from 1, so number of nodes will be n minus 1. So there is no node for the ground state. Okay. Now what about the first excitation? It is sign. So at x equals to 0, this value will be 0. And look at this. This is a by 4, minus a by 4. So for minus a by 4, it will be minus 1. So the curve will pass through this point. At plus a by 2, sign has positive value. So this will pass like this. You see, so this will be like this. Okay. So it has only one node here for n equals to 2. Look, n equals to 3, it is cos 3 pi x by a. So we check the value at x equals to 0. X equals to 0, cos 0 is 1. So it will pass through this point. At a by 4, if you check at cos is equals to a by 2. So here also it is 0, here also it is 0. And in between maybe a by 6 or something. Yes, you see a by 6. If you consider a by 6, it will be cos pi by 2. So at a by 6, 1/6 of this a, it will vanish on positive side, on negative side as well. And another side, maybe here it will show a maxima. Okay, so it will go like this. A simple trigonometric thing. So you can see it has 2 nodes now. If you remember, for the asymmetric case, I think it was something like this. It was going like this, right? If you remember, it was going like this for asymmetric case. But for symmetric case, it is taking this form. So these are very finite point, minute point, but you have to keep in mind. You can put different values of this. For a by 6, it is 0 here. Is there any question, guys? Let's move on to a question. Look, a particle is in the ground state of an infinite squirrel potential. You see, here minus a to plus a, the width is changed. Look, previously we discussed in the last section, we discussed that the wall is extended between minus a by 2 to plus a by 2. So the width was a. But here you see, it is given for minus a to plus a. So the width becomes 2a. So wherever you used a, it will now change to 2a. So remember this. The probability to find the particle in the interval between minus a by 4 to plus a by 2. So you know, if you are given any 2 point x1 and x2, what is the probability? It's simple, mod psi of x squared dx. So this is the probability to find the particle between x1 and x2. And you know, total probability when you calculate minus infinity to plus infinity, total probability we get 1, and obviously this is taken between 2 points, like minus infinity to plus infinity. This is the whole line. You just need to find out between a specific region. Maybe this is 0, so this is a by 2, let's say, and this is minus a by 4. So for this region, obviously the probability will be less than 1. Give it a try. Simple question. First thing first, what we have to do, you have to identify which state it is dealing with. It is dealing with ground state. So what will be the ground state? You know the function psi1 of x. Square root of 2 by a. A has been changed to 2a. Width is 2a. And it is odd value of n, so it will be decided by cos. Okay, n pi, so 1 pi x by a. So here a is equals to 2a. So wherever you see a, you just need to replace it by 2a. So what is the probability to find the particle between this interval minus a by 4 to plus a by 4? Therefore, the probability, required probability is equals to, the limit will be minus a by 4 to plus a by 2 mod psi of x square. So psi 1 of x, actually psi 1 of x mod square dx. If it is asking about first excited state, then you could have chosen psi 2x. So here it will be psi 2x. Whatever state it will mention, that you have to put in, and hence this will become minus a by 4 to plus a by 2 square root of 2 by 2a whole square cos square pi x by 2a dx. As simple as that. So you see this is 1 by a, and you can see if I just multiply half and then keep 2, so 2 cos square pi x by 2a. Now you know the formula that 2 cos square theta is equals to 1 plus cos 2 theta. You know, 2 cos square x is equals to 1 plus cos 2x, or if you write in terms of in terms of theta, then also you can write. So this is 1 by 2a minus a by 4 to plus a by 2, 2 cos square theta 1 plus cos 2 pi x by 2a. Okay. Dx. The first integral will give you x, and the second one, it is a by pi sine pi x by a, limit minus a by 4 to plus a by 2. Now let's put the value of upper limit, a by 2 plus a by 2, so sine pi by 2 is 1, so a by pi. Okay, then minus plus a by 4 minus a by pi, and another minus is coming from sine a by 4, so sine pi by 4, sine pi by 4 is 1 by root 2, and this a by pi will be there. Okay, so it is 1 by 2a, a by 2 plus a by 4, so it is 2a by 4 plus a by 4, so 3a by 4 plus, if I take a by pi common, you get 1 plus 1 by root 2. Is it matching with any of the options? Not yet, but hopefully it will match. Okay, let's multiply. So a getting cancelled, so this is 3 by 8 plus a get cancelled 1 by 2 pi. So if you multiply root 2, if you multiply 2, let's say, multiplying with 2, so 1 by 2 pi, so it will become 4 pi. So multiplying 2 on both numerator and denominator, so this will become 4 pi. So 2 into 1, 2 plus 2 by root 2 is root 2. Now I think it is matching with some of the options. 3 by 8 plus 1 by 4 pi, 2 plus root 2. Option A. Is it clear, guys? Tell me. Hari, Murli, Karthik, clear? Can you move to the next problem? Look at this problem. Consider the ground state. Again, ground state means psi 1 of x of an infinite one-dimensional potential well with wall at x equals to 0 and x equals to a. So actually this is asymmetric one. Okay, x equals to 0 and x equals to a. So this is asymmetric, no question about it. If wall is moved slowly to x is equals to 8a, then calculate the work done in the process. So you understood what it is saying. So you had, let's say, a particle in a box like this, 0 to a. Now it has been, the wall is moved so that it becomes a to 8a, something like this maybe. So you have to check zero to 8a. Calculate the work done in the process. What is the work done? Ground state you have to consider. The particle is in the ground state. Here also the particle is in the ground state, means n is equals to 1. Tell me what is the answer? It has been moved very slowly, slow movement. Slow movements, what does it mean? It means if the particle was in the ground state, after the movement the particle will still remain in the ground state itself. That is why that is what the significance of slow movement. Tell me the answer quickly, guys. Simple question. Work done. What is work done? Work energy theorem, you know. Work done is nothing but the difference in energy. Okay, na? Work done is difference in the ground state energies of the two systems. So which system will be having more energy, this one or this one? Obviously the first one will have more energy, because you see n square pi square h cut square by twice m, let's say write width square. So in the first case width is a, so if something in denominator is small, then the whole number is big, right? Now the width has been made 8 times, so obviously this energy will be less. So which one will be more? This. So pi square h cut square by 2m a square, this is the energy, minus the energy of this particle here, pi square h cut square by 2m, width is 8, so 8a square. We can just take pi square h cut square by 2m a square common, 1 minus 1 by 64, so it is nothing but 63 pi square h cut square by 2 into 64, 128 m a square, and that is matching with option B. Yes, Karthik, slow movement. Okay. System is slowly moved. So the system remains in the ground state in the new potential. Okay, let's do another problem. This came in June 2019. The wave function of a free particle of mass m constant to move in the interval minus L to L is psi of x. You see, this is non-normalized. A is a normalization constant. The probability the particle will be found to have the energy pi square h cut square by twice m L square. So very good question. This uses two concepts. You see, this kind of question, if you want to do, you need multiple concepts. First of all, you need the concept of particle in a symmetric potential well, and you need the postulates. Now in postulates we have talked about the probability to be in a particular state. Like if I can write the wave function or eigenvalue, let's say a1 phi 1 plus a2 phi 2 or something. What is the probability to find a particle in the state phi 2, or let's say phi 2 is having energy E2. So we can say what is the probability to find a particle with energy E2. So we have already given you in the postulates. So do it. Look at the given wave function. Psi of x is equals to a times L plus x, L minus x. So a times L square minus x square. So you can say this is an even function. Now the probability to find a particle in this at this energy. So for this potential box, for the potential well between minus L to plus L, energy eigenvalue, the general expression is n square pi square h cut square by twice m L square. Okay. So if you put n is equals to 1, you get E1 pi square h cut square by twice m L square. Acha, made a mistake. It will not be L, it is a width is 2L, right? So 2L square. So this is n square pi square h cut square by 8 m L square. Now if you put n is equals to 1, you get E1 pi square h cut square by 8 m L square. But here it is pi square h cut twice m L square. So it is not talking about the ground state. Let's talk about n is equals to 2. For n is equals to 2, you get E2 4 pi square h cut square by 8 m L square. So this is pi square h cut square by 2 m L square, and that is what the energy eigenvalue given to you. So we have to consider the probability to find the particle in the first excited state. For n is equals to 2, we know the wave function psi 2. Psi 2 is what? N is equals to 2 means n equals to even. So it will be decided by sine square root of 2 by width 12 sine 2 pi x by L. So this is square root of 1 upon L sine 2 pi x by L. Now what is the probability? The probability that the particle will be found to have the energy pi square h cut square by twice m L square, that is, we can say state psi 2, that is in state psi 2. It is not 12 in denominator. Yeah, we have done changes. Na? Is any portion left where we did not write 12? Here we have written 12. Okay. Here. Very good observation. And now is it fine? So what is the probability? You know the formula for probability. It is, look, we have to find out in state psi 2. So you know psi 2 psi mod square divided by psi. So from quantum mechanical postulates, we know this formula, right? So this is brass psi 2. Brass psi 2 will be square root of 1 by L square sine pi x by L ket psi. This is psi 2 and it is ket psi. Ket psi was A times L square minus x square, right? Modulus of this, modulus square of this. Actually, when we are writing this scalar product, it means we have to take integration minus L to plus L, okay, na? Psi to star psi dx modulus square divided by here minus L to L, psi star means A star, so psi star psi L plus x square, or you can just simply write L square minus x square whole square dx. Because you know, if you have, let's say phi 1 phi 2, so it is, let's say, minus infinity to plus infinity phi 1 star phi 2 dx. So here minus L to plus L. Now you see this function sin pi x by L, this is an odd function, and A times L square minus x square, this is an even function. So odd and even, product of it is an odd function. So product is odd. If product is odd, and you know, for an odd integrand the result is 0. Clear? So what is the probability? The probability to find the particle in the first excited state is 0. बताओ, कोई क्वेश्चन है आप लोगों का? Is there any question, guys, or confusion? Tell me. All sorted? Can you move? One last problem, then we'll wrap up the session. This one. A two-dimensional square rigid box of side L contains 6 non-interacting electrons. Okay, that's good. The mass of the electron is m. The ground state energy system of electrons in units of pi square h cut square by twice m L square is. Can you do this? 2D box. It's a 2D box. So what is the energy? E nx ny, side L, so pi square h cut square by twice m L square, and the quantum numbers nx square plus ny square. You have to consider the ground state. We have 6 non-interacting electrons. So what will be the ground state configuration? Look, the values of nx, ny can run 1, 2, 3, 4 and so on, right? So when you choose nx is equals to 1, ny is equals to 1, 2 electrons in each level, yes. So nx is equals to 1, ny is equals to 1. Then you get the energy pi square h cut square by 2 ml square. 1 plus 1 is 2. Okay. Now either you choose nx equals to 1, ny equals to 2, or you choose nx is equals to 2, ny is equals to 1. Both of them will give you same energy, right? that is 5, 1 plus 4, 5 pi square h cut square by twice m L square. It means this is a non-degenerate state. It is a non-degenerate state, and this is your degenerate state. Degenerate state means same energy eigenvalue but different eigenfunctions. So nx is equals to 1, so it has only one level. Nx ny equals to 1. But here you see the next state is nx denoted by nx is equals to 1, ny equals to 2. Another one is nx equals to 2, ny equals to 2. So both of them are different. Okay, they are unique. So you can imagine in this way. This is denoted by, I am just writing nx ny. Okay, 1 1. This is what? This is 1 2. This is 2 1. Now for the ground state, if you are given 6 electrons, so how the electrons will 6 electrons, how will they feel? So at one level, because of the priority restriction, s is equals to half, multiplicity 2s plus 1 is equals to 2. So in each level there can be only 2 electrons. So 2 electrons will come here, another 2 will go there, 4 remaining 2 will come here. Okay, the energy for this region, for this level is pi square h cut square by 2m L square. So 2 pi square h cut square by 2m L square, and for both these levels the energy is 5 pi square h cut square by 2m L square. So for this ground state, the ground state energy of the system, therefore the ground state energy of the system is, so you have to add all these energies. You see 2 electrons in this energy level, so 2 times 2 pi square h cut square by 2m L square, plus for these 2 it is 5 pi square h cut square by twice m L square. For these 2 same, so 2 plus 2 into 5 pi square h cut square by twice m L square. So you can take this pi square h cut square by twice m L square common, 4 plus 4 into 5, 20. So 24 times pi square h cut square by twice m L square. And I hope this is matching with someone. Option A. Clear guys, tell me quickly. So if everything is all right, we can stop the session here. Thank you very much. And in the next session, we will be discussing a very important topic, that is finite potential well. That is little bit tricky, but overall very easy. Finite potential box, and questions came many times from finite potential box and from this also, but the finite potential box is little bit difficult. Okay, so we'll cover that in the next class. Bye bye, take care.